Not hearing audio.
Okay, you're muted.
How about now?
There you go.
Okay. I think we're live. Although it still says I'm muted by host, but you can hear me, right?
Yeah, we can hear you.
There we go.
Yeah.
All right, so welcome to the Robotics Society of Southern California May presentation. Just for fun more than anything else, I'm going to talk about tri-wheel holonomic vector drive, which is more of a mouthful than anything else. I'm going to explain it in some detail, and I think we'll let's get this out of the way. Yeah. Be able to see it's actually kind of a fun thing to do. This all started 15 or 20 years ago with a robot project called the Palm Pilot Robot Kit. It was developed by a freshman computer science student at Carnegie Mellon University in the days before we had basic stamps or Arduinos or anything like that. He actually built his robot using continuous rotation servos. As you can see on the picture, the omni-wheel drive and a good old Palm Pilot, for those of you who remember the Palm Pilot. So the brains of this thing was a Palm Pilot. He figured out all the math and basically figured out how to make a holonomic drive. It was the first one that I saw. He sold it as a kit. I don't know how many he ever sold. But I decided to make one of my own. So years ago from scratch, I made this little hexbot. And it has the omni-wheel, 3 wheels, one in the back, sonar sensors, and up on top, it actually had 2 BX24 stamp upgrades, I'll call them. It had this gyro, which I got from a hobby shop. It was actually a gyro for stabilizing RC helicopters. And I decided to play around with this and see if I could get this gyro to work on my robot for heading hold. And I was able to get that to work, and it worked reasonably well, keeping the robot going in a straight line, with the caveat that all gyros drift. So it did well for short distances. It didn't do real well over long distances because it tended to drift. You might see a funny looking thing up here that looks like an old vacuum tube. It's actually a tilt sensor with a liquid inside. And I use that on different projects, but this is what we had, a tilt sensor with actual liquid inside to tell when it was level or tilted. And a gyro off a RC helicopter. This was state-of-the-art IMU 20 years ago for robot hobbyists. Not very sophisticated. Well, I've been into this whole idea of omni-wheels and tri-vector drive robots for quite a while. This was a more recent one that I built. I've shown this at the club. It has bigger omni-wheels. It has a Arduino Mega underneath, controlling the motor controllers that run the wheels. It has a NUC as the PC running on Windows 10. And then it has a LiDAR out of a Nito vacuum and a camera. So this thing ran on the NUC, on the PC platform, Tiger Slam, and I've presented that before, but Tiger Slam was able to read the LiDAR, create a map of the room, control the robot using the Arduino interface, and then do a version of holonomic vector drive with the Omni wheels. Another one that I played around with, you may recognize, was Rovio. And Rovio was a three-wheel omnidrive, came out of a box, and so it was something that was all set and ready to go. But I found out that by linking this using appropriate libraries, I could link this into ROS. And for a couple of years, I played with ROS and the Rovio system. I got very frustrated when ROS upgraded and the camera that was on this suddenly was deprecated and the ROS packages would not run this camera any longer. So as soon as it upgraded, I still could control the robot. I could still control the Omni wheels remotely over a Wi-Fi access point, but I wasn't able to look at the video anymore. It just sort of died. So I decided to move back to Windows, and most recently, you've seen the Slam Tech work that I've been doing. Some of you have joined in. Jim D'Annunzio will probably need to give us an update on some of the things he's working on. But I decided to build another little three-wheel omnidrive robot, and this is the base I bought. I got this from Seed Studio. It was $80. The bottom of it looks like this. It's got 3 wheels, 3 DC motors, and they actually have encoders on the wheels. I'm not currently using those. That might be a project for future development. But I do have the 3 motors, 3 wheels, nice little platform. To build it out, I put an Arduino Mega plugged into that, a sensor shield, so that I could bring out more pins. These are just I/O pins brought out from the Mega. But it also has a port for an XBee, a small radio transceiver. And by putting that on, I'm able to communicate between my desktop PC and my mobile robot wirelessly. And I can communicate back and forth without having to reconnect to the robot, which is handy. And I used a Adafruit motor shield plugged on top of everything else that actually allows me to run 4 motors if I wanted to run 4. I'm running 3, so this worked out fine. And it has power in of 5 to 12 volts to the motors. And then you can use the Mega to control the motor shield, and the motor shield controls the 3 Omni wheel motors. So putting it all together, it looks like this. This is the top view of the robot. I've got 3 wheels, A, B, and C. Here's that breakout board on top of the Mega, which is underneath. Here's the XBee radio, and here's the motor shield. So this is plug and play. It's about as easy to put this together as you can do. And to power it, I've got 2 LiPo batteries, rechargeable, 18650s. And it's running then at 7.4 volts. So this is the basic configuration. And now I have to program it to make the wheels work. But basic off-the-shelf stuff, making a really pretty sophisticated little robot for not a lot of money. In fact, everything I had here, the Mega, the Shield, the XBee, the motor shield, I had sitting in my drawer. So the way that these motors work, the way the wheels work, you have 3 wheels. This is the A wheel, B wheel, C wheel, and they're set 120 degrees apart from each other. This one, if you follow the blue dotted line, when it spins counterclockwise, it'll move in this direction. The B wheel, if you follow the dotted line, when it spins counterclockwise, it goes the opposite direction. And the C wheel, following the dotted line, counterclockwise would move to the left. The objective here is to input an angle, alpha, that I want the robot to go, and a speed that I want the robot to go. And that'll be represented by the V. It's not actually a vector, it's actually a scalar, but nevertheless, an angle and a speed. And this gets decomposed algebraically in the code, which I'll show you in a minute. So this wheel moves in this direction, but I have a blue vector arrow, and this is the direction I want the robot to go. So by taking the angle, subtracting that from 30 degrees, and taking the cosine of that angle, you project this blue vector arrow onto the directional arrow, and you get the amount of speed that this wheel needs to go in this direction to make the robot go along the vector arrow. So it's 30 degrees for this one, for this wheel, 30 degrees minus the angle, and you take the cosine of that to project it in the direction you're going. For this wheel, which is at a 150 degree angle, you take 150 and subtract the alpha, take the cosine of that, and that gives you the projection of your desired vector onto the wheel vector. This one is going in the opposite direction, so it'd end up coming out negative. The wheels spin backwards. But if this wheel and this wheel are both going in the direction of the green arrows, it's going to move the robot forward. And since there's a little bit of a shift to the right, this wheel compensates for that. It's at 270 degrees. 270 minus alpha, take the cosine of that, and you've projected the desired vector onto the wheel vector. And this little green indication is saying that this wheel needs to move this way slowly, while these are moving forward, and the whole robot's going to move in this slight right-hand direction. There's one other thing that makes these robots kind of cool, which is that if you want the robot to spin around its central axis, all you need to do is input a speed that's the same to all three wheels. If you input an angular velocity to this wheel in this direction, this wheel in its primary direction, and this wheel in its primary direction, it's going to spin the robot clockwise. So you can control the speed of spin by how big this angular number is. And you can control the direction by whether it's positive or negative.
You know, Dr. Bruce, I would have never thought to ask until you showed me how that worked. So that's a great explanation of planar translations for the three different wheels. Have you seen anything about planar translate plus rotate or arc-type motions? I wonder how they would break those down.
Like this.
Touche.
Glad you asked that question. That's what makes this so elegant. Now here's the algebraic formula. I'm going to show you the code on the next slide. But the velocity for each wheel, wheel A, wheel B, wheel C, is your desired velocity times that wheel's angle cosine plus the spin. Now they include here, it's actually technically spin times the robot radius. Well, the radius is constant. So that's a constant number. I'm going to ignore that and include it in my rotation. So all you do is you calculate the velocity for each of the three wheels and add in the spin for each of the three wheels. And you can make the robot go in any direction, doing whatever you want. Here's the code. For wheel A, I take my desired velocity, whatever it is, and this is on a scale of 0 to 255, our usual kind of scale. That was the wheel that had 30 degrees minus the angle. The angle was in degrees. But the cosine needs radians. So you have to convert the angle in degrees to radians. And you do that by multiplying by this number, which is just pi over 180. So this number times this scale factor converts this to radians. I'm taking the cosine. So the velocity times the cosine for A. The velocity times the cosine of this angle for B. Velocity of the cosine of this angle for C. And for each one, you add in the spin or rotation. If you want it to go straight without spinning, you just put in a 0. If you want it to spin without moving, you set the velocity to 0 and the rotation to some amount. And if you wanted to do both at the same time, you pick numbers. But it's one velocity number, one angle, one rotation or spin. And these three formulas are all the Arduino has to use to calculate the equivalent wheel velocities. And it sends those off to the motor controller.
So just as a brief question, if the rotation is 0 and you have it moving in the computed direction from all these cosine adjustments and contributions, are you saying that the rotation, that you actually make the body rotate as it's moving in that direction then?
If I put in an angle and a velocity and the rotation is 0, the robot will move along that vector and not rotate. So if I wanted it to go straight ahead, I would put in an angle of 0 and a speed of 200 and no rotation. And then it would just go straight ahead. If I wanted it instead, sitting here like this, I wanted it to go to the right, I could put in an angle of 90 degrees. And this whole, with no rotation, 0 rotation, put in an angle of 90 degrees, some velocity, 0 rotation, and the whole robot will shift to the right without turning.
Okay, that's what I was actually asking, that without rotation, it just moves without any kind of it just moves in the direction of that angle that you want. But if you actually want it to move in that direction and rotate as it's going in that direction, either clockwise or counterclockwise as you look down upon it, you then put in the appropriate rotation amount and it'll rotate at that rotational speed then.
Exactly. And there's the rotation. Yes.
Got it. Thank you.
And that's really.
And if you put both rotation and speed, it will still follow the straight line, right? I mean, it will not be curving as it goes.
Now, that's a very good question. What kind of results do you get when you start mixing these parameters? And I have an example or two to show you, so we'll get to that in a few minutes. It's fun to try to figure it out and then do it and see what actually happens.
It's a little harder with a robot like this if you want to, say, face forward all the time and drive the front of the robot in any along the path you want to go. It's a little more work than, say, a standard robot with 2 wheels, which generally is easy to keep the front pointed forward or keep the front pointed in the direction of movement.
Well, we'll see. We'll see that, Jim. Good point. So here's the formula that my code is going to use for the wheel velocities. And obviously it's pretty straightforward.
So Bruce, real quickly then, if you wanted the robot to move in an arc forward and say toward the right in a wide arc, you then would adjust the velocity forward, but you would also put in a rotational amount in order to create that arc, or so that the robot would always point forward then?
So you want the robot to move in an arc, but always point forward.
Correct.
Okay, I'm going to show you that.
Thank you.
But that's a great question. So I looked at this formula. I've looked at this a lot over the years. I really like the fact that you rotate, you send it in a direction and you rotate, and they're 2 separate variables and independent variables that somehow add up to create the robot's motion. So thinking about this rotation, I thought, okay, this is where I need a gyroscope. If I have a gyro that reads the z-axis, then I know if the robot is rotating. And as I showed from my head spot years ago, I could read that in and I could use that to create a heading hold. My robot has encoders, but I'm not using them. And I want it to go straight. So how does it know if it's going straight? Well, going straight means it's not rotating. So that's a heading hold. I need to monitor a rate gyro and see if I can use that information to make it go straight. So I went to Adafruit. I looked at a couple places. Adafruit has a number of different IMU and gyros, and they did some benchmarks on the different gyros that they have. The one that had by far the least gyro drift was this one, the FXAS 21002C, a really catchy name. And it comes on a little IMU package for 15 bucks. And that was exactly what I wanted, something that had the least amount of gyro drift compared to some of these are, some of these are significantly more. And it's relatively cheap, 15 bucks. So I got one of those. And this is what it looks like. This is the entire IMU, which has the 3-axis gyro, 3-axis accelerometer, 3-axis magnetometer. I'm not using most of it. I'm only using the Z-axis gyro. But it just takes power, and it works over I²C. So it's really easy to put on your robot. And in fact, here's the robot with the little IMU unit plugged in with wires. And I've got power, and I've got the I²C. And now my Arduino's connected up and reading the, it's reading the entire IMU. I'm only looking at the Z-axis rate gyro.
Dr. Bruce, this is Jim Uber-Setzig.
Hey, Jim.
I was thinking about the fact you mentioned that you can independently control the spin on a dime behavior, which is your rotation, compared with the translation, and they're independently specifiable. It occurred to me it might be a good idea to put sensors around the periphery of it that basically look out in different directions. And because you can control the rotation of the machine independently, you could cause any one of the sensors to point, shall we say, forward at any moment in time, which would be a handy way to switch between sensors that are looking in the direction that the machine is traveling.
Yes. Let me skip backwards for just a second. And this robot, which had the same OmniWheel setup, had 6 sonar sensors all the way around the periphery that did exactly that, Jim.
Yes, on the top, is that gadget at the top a camera?
There are 2 things. This gadget here is the LiDAR. That's a camera.
So if you wanted at a certain moment of time for the camera to point in the direction that the machine is traveling, let's say possibly to recognize an obstacle that's straight ahead, you could simply pivot the entire robot so that the camera points forward. You wouldn't need to have an independent motor to swivel the camera around. You could just pivot the entire machine.
You're absolutely right. You're absolutely right.
So Bruce, go back to your algebraic question or equation real briefly. The next one, that one. So where you have the rotations, this makes the assumption that the wheels are all rotating at the same rotational velocity or speed. Now, I assume that one, being a math kind of guy myself, I would assume that if you were to change each of those rotations, rotation A, rotation B, rotation C, you could actually get far more complex movements out of this entire robot system. Would that be a correct assumption?
Okay. Are you saying input different rotations here?
Yeah, for each of those, I take it those are the wheel rotations. Is that correct?
This is the rotation of the robot. It's the spin of the robot body.
Oh, it's not the actual rotational speed of the wheels?
No, that's computed. This is the rotational speed of the wheels. That's computed by multiplying your desired velocity, the velocity of the robot body, times a factor for each
Yeah,
wheel
got that. Okay.
based on the angle. And then if you want the robot body to be spinning, you add in a rotation, which is the same rotation for all three wheels.
Okay. All right.
This will be different. This calculation, this part of the calculation is going to be different for each wheel.
Right. So the VA, VB, and VC then are actually the rotational speeds of the motors to the wheels then.
Yes.
Okay, I got it. That.
Yes.
Thank you.
Yes, you got it.
I was going to say that brings to mind for me the fact that you'd still have to use a control loop or control PID or something to make sure that the actual velocity of each wheel is calibrated, right? So you still need to do that. It's just for 3 wheels instead of 2.
Well, you bring up an interesting point, and the question is, do you need PID on each of the 3 motors? And ideally, I think you probably would. I just got done telling you I don't do that. I am trying to correct any problem in the motors, the motors not being exactly the same. So even though I might be putting in numbers here, and I think the robot's going to go a certain way, the motors are not exactly identical. The computations will tell me what I want it to do, but it may not translate in reality because the motors might be slightly different. I was curious if I could correct for that with the gyro in this rotational parameter without using motor PID. So let's see what happens when we do that. So this is my first little test. This is almost all the code. I have a subroutine that I wrote called drive. I input an angle in degrees from 0 to 360, whatever I want. I input a speed. The speed is from 0 to 255. So 200 is what, 75% of the max speed. I put in a number for the spin or gyro rotation. And then I tell it, the 4th parameter, how long do I want it to do this? And in this case, I'm putting in 100 milliseconds. So I want it to drive, I want the robot to drive at this angle at a speed of 200 with this rotation for 100 milliseconds, a tenth of a second. And I put this in a loop. Here's the for loop. It's going to do this loop however many times I set in the counter. The counter is calculated as the distance I want this to travel times a conversion factor. And I had to calibrate this. So it turns out that 11.76 times through this 100 millisecond loop, if I did that 11.76 times, that's about 1 foot. So if I put in a distance of 1, it'll go through this, well, it'll round that off because it's integer. It'll go through this 11 times, it'll go about 1 foot. If I put in 10, it'll go through this 117 times. So if I put in 10, it's going to go about 10 feet. But the point of this was to see whether or not the gyro could correct to keep it going straight, create heading hold. So I initially zero out the gyro. I turn on the IMU. I enter into my loop. And the first time through the loop, I get a reading off the IMU. And I'm only interested in the gyro Z axis. So this will return the reading from the Z axis of the gyro. And it turns out all gyros drift. I happen to choose one that drifts very little on purpose. And after calibrating it myself, this was the calibration number. And what was really interesting about this particular gyro, and I've used several gyros over the years, it drifts by this amount fairly consistently. So when you recalibrate, you get pretty much this same number over and over again. I didn't have to put in a separate gyro calibration code. I just used this and that Adafruit IMU and the gyro that's on it not only doesn't drift very much over time, the amount that it drifts is pretty reproducible, which is something I don't usually talk about. But it was really nice because I could calibrate this once and then use this offset for all my measurements and multiply it by 100 as a scaling factor or a proportional factor, if you will. Add that into the gyro rotation. I'm just keeping a running sum of all my readings every 100 milliseconds. Read the gyro, add the number, output the new gyro number. Same drive function. But every 100 milliseconds, I'm going to do 2 things. I'm going to output a gyro correction, a spin on that rotation. And in addition, with this particular loop, it's going to output, I set the angle in this example to 0. It's going to go straight ahead and it's going to correct the gyro. It's going to go to speed of 200 and it's going to keep doing this loop every 100 milliseconds until it's gone a distance of 10 feet.
Quickie interrupt here. Do you know if the gyro itself is built upon semiconductor electronic, electronic device or something? Or because I'm wondering why you would get such a repeatable error, that 0.010715. It would seem that perhaps the manufacture of this or the physics design of it is such that you get repeatability because of the internal electronics of the gyro itself.
I'm sure you're right. I suspect if I got a different, if I got a new board and a new IMU, same company, this number would be slightly different. But I would hope that if I got a new board or you went out and got a board and calibrated your board, while this number might be different, a little bit different, hopefully not much different, hopefully it wouldn't change much reading to reading, as mine didn't. It was reproducible. And
I
this
just
is no-
I suspect the reproducibility is because it's based upon some kind of semiconductor junction, reading of magnetic field or something like that, Earth's magnetic field or whatever it is. I don't know.
Well, it's gyro rotation, it's not magnetic. So I don't know either, but I was impressed with the results. So
You
let's
got-
see.
Dr.
Any other
Bruce,
questions at that point?
so the I wanted to ask that the event.gyro.z there, or essentially you're adding in, now that is going to go positive and then negative and positive and negative, I assume is what's happening.
Yes,
And that's that's going to keep it straight.
yes, exactly. If it goes, let's see, what was it? If the number was positive, it meant the robot was rotating clockwise. If the number is negative, it means it's going counterclockwise. And so I just multiplied it to scale it, added it into my sum, my running sum, and threw it into my drive rotation, and it kept it going straight.
Cool.
All right, let's take a look. So my claim is that if everything I just said is true, then I can put in a distance of 10, meaning 10 feet. I'll go through this loop 117 times, gets truncated because it's an integer. Correcting the gyro with an updated heading every 100 milliseconds. And if I set the angle to be 0, it should go straight for 10 feet. And the gyro should compensate for any deviation in its direction, even though I don't have PID, and I'm not on my encoders, I'm not using the encoders. So I marked on the floor with a line the start, and you'll see this in a minute. I put the back wheel on the starting line, turn it on, and it should go 10 feet and stop at the 10-foot mark. So here we go. And it's off. You can kind of see the cracks in the wood paneling and see it's going straight. And that's the 10-foot mark. So I think this was pretty successful, that it actually went the desired distance. And it really did this with the first run. I did it several times just to film it, but it was really remarkable that all that theory actually kind of worked out. Are we ready for the next one?
How long did it take you to find that scalar value to adjust motors?
You know, that's an interesting question. It took me about 4 or 5 attempts. The first time I picked a really, I used kind of the Newtonian approximation by halves. And the first time I put in a low number, 5, and it just drifted off. It didn't go straight at all. So then I put in 500, and it just sat there and wobbled back and forth. It was kind of pathetic. It didn't go anywhere. So 5 was not enough, and 500 was too much. So I just kept scaling the number. I picked a number halfway in between, and I think it was on the 3rd or 4th try I got to 100, and that worked fine. So I might be able to fine tune it even more than that, but it works. So that's the number I've used.
Very impressive. Very nicely done.
Thank you.
It's usually more considered more art than science, is adjusting those numbers. I've worked on some PID constants, and it's like there's some method to the madness, but well, you can read about it, but ultimately it's kind of hard to understand it rationally.
And for something like this, it really is easy enough to get it by trial and error. It just isn't that time consuming.
The thing that I noticed, which is really intriguing, is that your end marker, where your wheels are relative to that end marker, from a horizontal view from where we're at, the error on that little piece of tape or whatever it is that you use there, the wheel is lined up almost centered on that thing.
We'll do it again just because, but yeah, I thank you, yes. And you'll notice we're going forward, these A and B wheels are running. This wheel isn't used really. It uses a little bit to correct, and boom. Yeah, so going forward, it just runs these wheels in the forward moving direction. And this is a drag wheel when it's going in that direction. So let me show you a different one. Now in this one, I decided to go forward 3 feet and then go to the right 3 feet, then go backwards 3 feet, and then go to the left 3 feet. Again, remember, I'm not using odometry, I'm using a timer. And I'm using the gyro to keep the robot facing forward. So if you watch as this moves, and kind of watch the wheels, when it's going in this direction, it's going to be these 2 wheels. When it's going to the right, all 3 wheels come into play. It's kind of cool to watch the checker pattern as it's moving 90 degrees to the right. So we're going to draw a box. We're going to draw a square. And I've marked the starting position in the blue tape. And here we go. And it made all those movements and faced forward the whole time. And it came back pretty close to where it started. So that's not bad.
A social distancing high five to you.
Yeah, that's
That
hard.
is amazing. I mean, the error of all of those movements back to its position. I mean, you're what, about an inch or so in error to the, I guess from our view here, to the right of where you actually started. Only 1 inch approximately, if I'm
Yes,
estimating right.
yes.
That is really impressive.
It is impressive. I spent like wrote an entire odometry system on the Lego robot, and it didn't do as well. I mean, it was like thousands of lines of code.
So now the question is, can we do a little more complex shape? One of the things I like, we just did a square, and the nice thing about it is if you need to move left or right, you just move. You don't have to turn and move. You just move. So let's try a little bit more complex shape. And I'll let you guess if you want to guess what this is. But
Are some of the UFO reports due to your work aerodynamically?
Excuse me, this is Jim Ubersetzig. I wonder who was speaking last? I don't see a name associated with the voice.
This is Buzz and Linda.
Ah, thank you.
Who's that, Arthur?
anyone want to guess what that shape was?
Is it a hexagon?
Yes, hexagon. 3 feet on a side. So we just did the exact same concept, moving different angles and running for a certain amount of time, corresponding with 3 feet.
Could you replay that again?
I would love to. Here we go. And it makes a hexagon. And watch the wheels. Straight. 60 degrees. The other way. Straight back. Reverse. And you'll notice it's not rotating. It's facing forward the whole time. And ends up pretty darn close to where it started.
Cool.
So let's go just for a second. Now somebody asked me, but let's let's actually answer your question in the next demo. If I change the angle, and let's suppose I put in a counter here, and I change the angle according to the counter I. So for the first 100 milliseconds, it's going to go in the 0 direction. The next 100 milliseconds, it's going to go 1 degree clockwise. The next rotation, 100 milliseconds, it's going to go 0.2 degrees clockwise.
So you need another for loop in there that actually increments the angle as well as increments the time counter. I will increment the time counter, and maybe J or K or something will increment.
No. Yes and no. I'm just going to take this out and put 360 in here. And I'm going to take that I and stick it in here. So the angle becomes I. Counter becomes 360. So every time through the loop, I gets incremented, I've now put I in the angle slot. So every time through the loop, the angle is going to be incremented by 1 degree. That makes sense?
Yes, it's the KISS principle. Keep it simple.
Yes.
I made it a little more complex so you didn't have to do integer changes, that you could do fractional changes if you wanted to by using a second.
Now I'm still doing the gyro rotation to keep it facing forward. So let's see what happens when I make that one change of adding. That's a good question. Which one is it? Okay, it's this one. I'm now going to make the drive angle change by 1 degree every 100 milliseconds. And it'll go from 0 to 360. And while always facing forward, it drives in a big circle.
You could probably change the radius of that circle based on how many degrees you change it.
How long you run it, not degrees.
How
but
long?
If I run it for a longer period than 100 milliseconds, circle gets bigger. If I make it less than 100 milliseconds, circle gets smaller.
Still very accurate.
And here it is back at the home position. So again, let's do the circle.
I'm definitely going to get one of your gyros. That's better than that 9250 that I've been playing with.
It was so easy.
I mean, I was using this whole AHRS, Kalman filtering code. I mean, it was incredible for like code for keeping a drone stable, but it was just kind of complicated and a little error prone, I guess.
Well, again, I'm back to saying this is a two-dimensional problem as long as the robot stays on the floor on a horizontal surface. I'm really only interested in the gyro, the Z reading off the gyro. And again, here it is after having gone all the way around the big circle, still facing forward.
So Bruce, this is Buzz again. This error, when you wind up at your ending position, close to your starting position, do you attribute this to some of the error in the round-off error in your computer calculations, or is this due to mechanical error due to the motors themselves and the wheels and all of the mechanical stuff like that? The reason that I ask this, because if you were to send this thing off for a long journey, the error would accumulate. I mean, if you wanted to zero in on a target or something, maybe 300 or 400 feet away, you might not wind up quite as close as you have with these shorter duration movements, or journeys, I should say.
Well, you're absolutely right that in any system, no matter how well you tune the PID, the encoders, whatever, you have cumulative error. So this is pretty good for something that has no encoder. And yeah, I think the answer is probably it's round off error in the conversion from floating point to integer. And I could probably tweak that just a little bit. I mean, again, it's good enough. For what this is, it's good enough.
Yeah, for sure. Agreed.
But your point is well taken. It has an error, And if I were to continue to do another circle and another circle, the error would get worse and worse. If I just did 10 laps, the error would be significantly more than this.
Still pretty impressive as it is, I must say, especially with the simplicity of the equations that you've used and the amount of code you used. I mean, that is amazing. You've done a wonderful and magnificent job of this and explaining it to the rest of us.
Well, good. Thank you. I have future directions, but let me show you one more demo. Because I think somebody asked this question. All the demos I've shown you so far are the robot moving in some direction, changing direction, doing something, but always facing forward. So the question is, can I move the robot forward, the body of the robot forward, while simultaneously rotating, let's say, counterclockwise? So here's a short little video. Watch it move counterclockwise, but it's still going straight as it went along the lines of the floorboards. And yet it rotated from going the 12 o'clock position to the 9 o'clock position.
Wow.
And that's using gyro, right?
That's using the gyro. Let's do it again.
Dr. Bruce, may I ask you a question? You are obviously not using encoders here.
No, correct.
And if you were using encoders and if you had control over the actual speed of the motors opposed to the power that you apply to the motors, then the formula would work exactly, I mean, adjusted to slippage of the wheels, but probably wheels are good enough and they're not slipping too much. What I'm saying is that you are using gyro to compensate for the differences in motor, power to speed characteristics.
Absolutely.
And have you, I mean, you obviously haven't yet gone to the phase when you are using encoders and therefore the odometry will work and everything else, right?
Well, I'm kind of convincing myself that I don't need odometry for this.
Well, maybe I misspoke. I mean, when I say odometry, what I mean is that if you control the actual speed, actual rotation of the motors opposed to the power that you apply to the motors, then the odometry formula will apply and all your cosines and sines and omegas will work exactly as the math predicts.
Yes, and I suppose we should break out the terminology a little bit. I've been a little bit lax here. If I use the motor encoders, I could use them to do PID on each motor to more accurately control the motor's speed. I think I've demonstrated that I don't need that because the gyro compensates for differences in motor speed without resorting to reading the encoders.
And that's exactly the beauty of your presentation. You know, I mean, that's very unorthodox way of thinking and applying, you know, electronics to compensate for things that could be done otherwise traditionally, you know, through, you know, closely controlling the motors. Instead,
Now,
you are
let me,
the motors run as they are, but you compensate with the, you know, the other means. It's beautiful. Thank you.
thank you.
It's
Now,
almost like this version of you know, a three-wheel robot actually benefits, maybe it's more from the having the gyro, or I mean, it's easier because if you only have two wheels, then and you don't have a PID on those wheels, you've got less. I mean, it's harder to keep. It's harder for that gyro, I think, to keep it straight, because with the, it seems like with the three wheels you've got more play involved. You've got more play involved. I mean, it's just a hunch.
The beauty of this method actually is that you can work on slippery surfaces.
yes,
Imagine that if you were relying on the actual, you know, closed loops control of the motors, and then the wheels would be slipping, then odometry would not work per se, and you know, the robot will deviate. With the gyro correction, it will stay on course.
yes. Now, to further address your observation, Sergey, the next step, I'm not using the encoders, but I have a platform that I can drive in any direction and drive it straight. So if on top of this, I were to add a SlamTech LiDAR and feed the encoders, which I'm not using anyway, feed the encoders into the SlamTech unit so that it kept track of odometry, the SlamTech could direct through the Arduino, direct the motor control, and do course correction with mapping. So that if I were to draw that circle or any other figure, any other robot motion, the SlamTech unit would be the anchor that would continuously update the navigation and the map and tell the robot where it is on the map and drive using the omnidrive. Jim, does that make sense?
Oh yeah. You know, as we, you know, you and I talked about, the SlamTech has even sample code for that, bringing in the three-wheel omnidrive, and it's just but they do, yeah, and they will use odometry, and through the calculations, it keeps track of where it is. But it will use the PID loop to try to keep the wheels rotating at a velocity that it wants. I mean, if it says I want 3 centimeters or per second or something on each wheel, it needs to the PID will be used, I mean, to try to keep each wheel at that speed.
Okay, I mean, that's fine, right? So I have 3 encoders that aren't being used that could feed into the SlamTech. The SlamTech could feed 3 motor drive commands to the Arduino. The Arduino already has the motor driver unit plugged in on top as a shield. This base platform is basically ready to add a SlamTech unit.
Yeah, I think it would be really cool to try it out. I mean, and see this, as long as there's enough pins, like I said, it seems like you could squeeze it in and have a third wheel and a third encoder. And it looks like the SlamTech people have already, proven it works, with the because there's sample code.
Well, that's my presentation.
Well,
Thank you very much.
Bruce, one other thing, nobody has brought up the issue, and as a double E myself, it occurs to me that as your batteries drain down and the voltage essentially reduces somewhat, that would affect the rotational speed of your motors somewhat. So these techniques obviously could compensate for that as well. But do you find that there is some significant change in speed as the batteries discharged to a lower voltage?
Actually, yes. I try to keep the batteries charged, but yes.
But even, yeah, I mean, as you do these experiments, even though you keep the batteries charged before you start, probably, as this device runs, it drains and it will cause some voltage loss, which will translate into slower motor speed, even if it's small enough, So these techniques with the gyro and possibly your LiDAR stuff would certainly compensate.
Yeah, you dropped out there, but yes. And one way to partially compensate for that is to run the batteries to a voltage controller and then through the voltage controller to the rest of the equipment, so that even if the batteries are draining, you get a fairly constant battery voltage supplying your robot.
Yeah, a voltage regulator would do that job for sure. Yeah. Thank you again.
Thank you. Alan, back to you.
Yeah, first off, thank you very much for sharing that tonight. That was amazing so far. Hand clap, applause, and things. Thank you. All right, so this completes the main part of our presentation. Although we keep offering it every time we get together, it's kind of an open session now. If I'm not mistaken, Ben, we can do a little bit of show and tell, or just hang out, or break out into groups. Did anyone want to do any show and tell tonight? All right, Danny, you raised your hand first. You are up first. What's going on? Let's see.
Sorry, hang on, let me. Okay, so okay, so first let me show you a picture of some concept art that someone named Steve Corman did for Star Wars droids. So it's not a droid that appeared in any of the movies or anything. And they named it DD3, and it's a programming droid, and this is what it looks like. Can you all see?
Yeah, that's coming across.
So it's kind of meant to be like, related to R2, sort of. It's got the dome and whatnot. So anyways, I wanted to make one, an interactive one, and hopefully it'll work. Let's see. It's very simple, okay? But, so. And he's on a donut stand, actually. So it kind of looks like he's hovering. And he's supposed to be interactive. So I programmed him to have 8 different responses that are beeps of different types. And they're randomized. So you don't know which one he's going to do. And it has a sound sensor right here. And this is the speaker. And then he has a servo to turn his head, so it looks like he's, interacting. So it's kind of like you can ask him questions, and depending on how his response is, you could respond back. It's just to make it look like he's interactive. Anyways, hopefully you can hear his noise. I'm not sure. Tell me if you can hear his first beep. Did you hear that?
No.
No.
Darn it. Okay.
Now, did you make this from scratch?
Yes. Let me find out where my speaker is on my computer, and maybe I could hold him near it.
Your camera, right?
What'd you say?
3D printed or?
No, this is just foam pieces, and this top is a Starbucks lid, and this is foam that I carved, and I carved out the middle to put it inside.
I hear something now.
Are you the one who made that that T robot?
Yes.
Ah, okay, yeah, pretty creative stuff. I remember now.
Oh, thank you. So he's talking. Every time I talk, he responds, but could you hear that? Hold on.
Yeah, I hear that.
Yeah, I could hear.
So he has different responses, but it's hard for him. But yeah, so anyways, he has, and some of his responses are meant to kind of sound like, not grumpy, but kind of like, beep, 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 you know, so instead of all just happy noises. So anyways, I named him DD3/8 because he's smaller than the original DD3. And I also want to make a larger one that has a ultrasonic sensor on it so that when someone is a certain distance away, he'll make a beep response that's like positive, and then if people get too close, he'll make like an alarm sound. So I thought that would be fun. I already coded that part, but I haven't put it in the robot yet.
What are you using in
Pretty
your
cool.
input right now?
Danny, that's adorable.
Thank you. I had a lot of fun making it.
Oh, I bet.
It took forever because I got the electronic part and the coding part done pretty fast, but I messed up on the body so many times because I was using different materials, and I found this Bondo in the garage that I wanted to fill in like the cracks, and it ended up like eating the styrofoam, so I had to.
Yeah, that happens a lot.
Oh, it was so frustrating. I had to dig it all out and then cut more pieces of styrofoam and shove them all in and glue it, and then sand it, and I bought a Dremel to smooth it and all that. But anyway, so the part that took forever was actually the crafty part, because that's the part I'm a little bit less interested in. I'm more interested in the coding part. But it was a lot of fun though, and I'm gonna make a few more, but like I said, different sizes that have different that can do different things. And
So-
actually, well, yeah, but go on. I'm gonna grab one more thing, but hold on.
Do you use a servo to move the head back and forth then? Is that the deal?
Yeah, it's an SG90, just a little small cheap one.
Okay, thanks.
Good job.
All right.
And then, hang on one second, I had to go grab something. Uh-oh. Oh, shoot, his head fell off. Hold on.
It happens.
Oh, no.
So I made these guys a while ago. Like, I was gonna bring them to the meeting that we have in person, and then right then is when the meetings got shut down. So I made
Oh, that's
Nice,
cool.
very nice.
Oh, yeah.
and he has the back of his little thingy opens up. Hold on, so I can turn on his lights.
Oh, that's cool.
So he's got, you can see his light, and then on the back, yeah, it's lit up, his little grid thing.
Oh, that's
This
a
is
nice
my
effect.
video game, the Fallen Order video game.
Are you using NeoPixels for the back?
No, it's actually just a string of LEDs, and then I cut these out with a hole puncher. It's very
Ah,
That worked.
look at what I have here.
that is cool. And one of these days,
This is NeoPixel. That's for the back for that droid.
yeah, that is cool.
Yeah, so this is pretty cool. So, yeah, so
Pictures of that.
that's really nice. You did a great job. But yeah, this is what I've been playing with. This is the NeoPixels for the back of that particular.
Yeah, I really like that. Eventually, I hope to go in that direction once I get more skills. But this guy, he's mostly made out of foam, and then I used Lego joints in his knees so that he can be folded. And then
Wow.
That's nice.
because
That's so cute.
Clever.
in the video game, hang on a second.
Walter, is that your computer room in the background there?
No, this is just my messy office.
Well, nothing but bad. Hey, I just joined another robot group. I'm now in the medical droid one.
Nice. You know that she should put the droid on the. There's a BD1 builders group on Facebook. They would love to see that.
Oh yeah. Yeah, these little boards I got are going to be pretty cool once I figure out how to use them.
I'm back. I want to show you one more thing really quick.
Tim, what group did you join?
It's the I'm in several robot groups. I'm in the this one is the medical droid. Let's see, forget the name of the number on the droid, but it's the medical droid builders group. Star Wars. So I remember the medical droid in what was it? Return of the Jedi. When Luke is in that tank, the droid that's standing next to him and probing and all that.
I see.
It's a group that builds that, and I'm also on the RX-24 or the builders group, which is the one that Captain Rex droid from Star Tours.
So Danny, these are twins?
Yeah, so I made two of them. One's a little bit smaller than the other, so his name is BD1/2 instead of BD1. But he doesn't have the lights. But what I wanted to show you guys was their joints are a little weak, so sometimes if you put them down, they collapse. Like their whole head just goes klunk. So that's a little difficult. But I wanted to, in the video game, this droid rides on people's back, the main character's back. And so I wanted to make it so that's why his legs can bend, so that he can, I gotta find the picture. Sorry.
There's 3D models out there that you can put in your 3D printer, and you can scale it up and down any size that you want.
Yeah, I do. I just got a printer, so I am gonna eventually print one, but I wanted to, I'm building like a harness thing to wear that he can, find my picture of, here we go.
Yeah, it's like Walter has a backpack to carry the large one he has around.
Yeah, so this is like, don't mind it's just a picture, but I'm kind of wearing PJs and stuff, but so like, you can you see that?
Yeah.
Oh yeah, hey, that's pretty cool.
So it like hooks, so see how his feet are? So he kind of looks just like that in the video game. He sits on the guy's back with his feet.
Yeah, he's a little smaller than that, but yeah, he sits on the back and uses it to, uses
if you look at my so I'm the guy on the photo there that you see.
Cool, that's awesome.
So that's me, and I carry BD1 on my back like that.
That is awesome.
Yep.
I love it.
How big did you print that one out, Walter?
That one is about 30% larger than the one on the video game, because I'm a big guy, so I wanted it to look my size.
Aha. Well, I mean, you're big for a Jawa, yes.
And for a Jawa, I'm pretty big, so yeah.
Yeah, you're official Jawa for the 501st Infantry Group there.
Yeah, but yeah, BD1 is a really cool one. You need to show it on the Facebook groups for BD1 builders. They will love that. Yeah, they would love it. Yeah.
I mean,
like one of my favorites. The second I saw him, I was like, "Oh my gosh!" I was so.
When I get through making the Baby Yoda one, I'm going to make the RX the droid that's in this August Cantina at Galaxy's Edge there, the DJ droid.
Oh yeah, DJ Rex.
Yeah, which is the Captain Rex from Star Tours robot, just retooled a little bit.
You can kind of see him there a little bit standing up. He looks a little rusted, so I left it rusted color.
Nice.
And I made this last summer, and the game wasn't even coming out till December.
Yeah.
So if you look at the video game, one of the colors you can pick is, guess what? That exact color that you see right there.
Yeah.
You're kidding me.
All the blues and teals. So one of mine's blue, and the other one is kind of like a metallic teal color.
Yeah, very cool.
Well, I'm going to be painting up my Yoda thing in this next week. I think I showed it before, but here's what it looks like. It's standing on my desk here. You see it?
Yeah, that's really coming along.
Yeah, it's all together. And I'm debating whether to take the arms completely apart and paint or just paint them all together. I haven't decided which one I'm going to do yet, but because I'm going to prime it and paint it this next week.
Where's the eyes, Tim?
I don't have them in there yet, but I do have them. I do have a pair that I printed out.
Okay. Anybody else have anything else for show and tell?
Where am I here?
Well, looks like Thomas is raising his hand.
Thomas?
Hi. Thank you, Danny.
Yeah, for Danny. Yay!
Yeah, eyes look like.
Okay, so I put together this thing I called my barefoot walker. And I'm going to show the background. You can't see what
Yeah, can you get rid of the background?
Sure.
Okay.
So this is what I call my barefoot walker. Is it in the screen? I can't see so well.
Yep, yes. We can see it.
Yeah.
It's basically an auto, it kind of extended, and instead of legs, it's got feet. It's from wooden stirrer sticks, not exactly popsicle sticks, but in the same category. And I've been messing around with it, and finally I got it to walk. And I'm not going to show it to you live walking. I'll give you the video since the batteries I have weigh it down too much, and so it wants to topple. And so I'll show you the video. Let's see if I can link the video.
You switched to the standard servos, or those don't look like the micro servos? Yeah.
Yeah, these are
yeah, the standard servos.
High-tech 311s.
Yeah.
You see that?
Yeah, yeah.
So move him onto your shoulder so you can see how tall he is. Yeah, there you go.
Oh, cool.
Perfect.
Yeah, he's a lot bigger than a standard auto.
Yeah, that's a great shot. That way we can compare the size of them.
Yeah, let me grab I bought an
auto
kit here, and I got it running. It gave me a lot of problems. What happened was there was some change to one of the boards, and it's drawing too much power, and now a standard battery doesn't work. And then you had to connect your battery pack directly to V++, the 5-volt supply or something. VN is it, or is it 5 volts? The 5-volt supply. Anyway, it works now.
That's
and
cool.
So does this, and this one has the same problem. It needs a lot of power, and if I try to power it off the batteries, it just doesn't work. So either I got to get some really.
You posted a video on that not too long ago, didn't you, with that walking?
I did, and I'm going to show it right now if it'll connect.
Yeah, you need to beef up your legs there, Tom, with something more sturdy.
My legs, fine.
Creatine.
The legs.
Hey.
Did I put what on the leg?
Batteries. I mean, you can put heavy, big batteries on the legs, and that will solve your problem.
That's a good idea. Thanks.
Ride a bicycle.
Hey, that'll work.
Okay, so let me see if I can get the video to come up. Hold on. So if I want to, let's see, I want to share a screen. Let's see if I can figure this out. Okay. So,
I haven't tried setting up Zoom on my laptop yet. I think might do it next time around.
There's nothing to set up. You just click the link.
Oh, I mean, I haven't tried it on my laptop. I'm on my cell phone. It's a little easier for me to handle.
can someone tell me how to share my screen? Do I hit that green button that says share screen?
Yes.
That's right.
That's it.
Just hit
That's
share.
fair.
As long as Alan let you in.
Push the button, Max.
Can you see it?
Yep.
There it is. Yay.
All right, well, here we go. This is the only video I have of it running.
Go, go, go.
You can see it's plugged into my computer.
Okay.
I'm talking. Obviously, you can't hear that. I can't hear.
I see the arrows on the feet indicate the preferred walking direction.
Yes, yes, it's better that way. So I don't have to guess which is the right and which is the left and which is forward and backwards. There we go. Kind of drags the right a little bit, but.
Are those toes made from the paint mixing sticks or something, or tongue depressor?
They are. They are.
Oh, that's pretty cool. Play it again.
Play it again.
Yeah, it has a very auto gate to it, doesn't it?
Yes, it does.
Uh-oh.
That is standard auto code.
Okay.
I had built this thing, God, 8 years ago. And it had knees, and I took out the knees. I said, well, let me try making it into an auto because I never got it walking as is.
Oh, still pretty cool to see it work.
Kind of
Wow.
lumbers along, you know?
The first move was like a karate kick, actually.
Reminds me of that, yeah.
I commented it was a candidate for the Ministry of Silly Walks, if you remember.
Yeah.
That's great.
Monty Python, 1980s.
So Thomas, the upper part of the legs look like they're pivoted in some way to be able to rotate, so that the body, the blue body, can move back and forth in a rotational way above the legs.
Yeah, I'll show you that if you'd like to see it. Hold on, let me shut this shared screen thing off. Stop share. Okay, here we go. Hi, Tam. Here, so
Hi, Thomas. You started it.
How do we get the camera back on me?
In the video? No.
Okay. So.
Am I not sharing my screen? Is that what I'm not doing?
No, you can see it, but you need to move the legs up and forward a little bit so you can see underneath.
Oh, that's good.
Yeah. So what kind of pivot is that there?
Standard servo motor.
Oh, okay. Got it.
I cut a hole in the blue plastic piece.
Yeah.
And push the motors through, and just very simple. I built this thing so I could build this thing.
Well, you need a prototype, right?
I wanted to know, how it walked, what made it walk, and could I adapt it to a bigger robot? And somewhere in the back of my mind, I have this idea: I'm going to make this thing 4 foot tall, but I don't know if I'm going to. Yeah, a 4 foot tall one of these. Can you imagine that? But I think I would have to change a lot of it. I think the math would have to change, and there's no math, right? Alan, you said these numbers were fixed, and I'd have to find my own numbers.
Yep, you just have to find the right magic numbers, man.
So you'd probably have to put in Dr. Bruce's gyros in order to stabilize the thing and work out the math for the various servos.
It gets a whole lot more complicated if I went 4 foot with this thing, for sure.
Yeah. Yep.
There's an oscillator. The oscillator code is what I had to play with to try to make mine walk straight and turn right and left, properly. But that oscillator code, it's pretty straightforward, and you can see the interface to it. You just have some numbers you can adjust, and it's not too difficult, I think, to adjust it to different servos. You have to, just do one at a time.
Yeah, well, it's gonna go on the back burner for now because I'm working on this new fembot project. I'm basically taking Betty 9 and putting skin on her and putting in some AI, right? It's all canned right now, so it's easy to use.
Oh no, you're beginning to work on real dolls?
Won't do that. No, don't put me there.
Hey, if you want to check it out, I know a guy. I actually met him a few years ago. They're pretty, he's a character.
I
Is
think
it
he
gonna
was
go brrrr?
recruiting RSSC engineers.
Yeah, I'm putting up a whole series on building my fembot. And like I said, it's basically going to be another Betty 9. I haven't got a name for it. I was thinking like Simone or something. I actually contacted Simone Gertz. Is that her name? And asked her if she wanted it modeled after her. I never heard back. So I think I might use that name because I like the name because there was that movie Sim 1 or something. Simone, the artificial actress or something.
Oh, her YouTube clip where she auditioned for Westworld?
That's a different one, but yes, I saw that one as well. I
Well,
doubt it.
Speaking of fembots, did you ever watch the movie Cherry 2000?
No.
You didn't?
Yeah, it's an interesting android-oriented, female android-oriented movie with a love triangle. It's either the human or the android. You know, the guy has to make his choice, so to speak. And it's an interesting sci-fi flick.
I was inspired by both, what was it, Sophia? And I said to myself, I can build that. I mean, Sophia is, basically, Betty 9 with skin.
Yeah.
And also that movie that came out a couple of years ago, what was that called? The one where the rich guy lives on the far away and he has somebody come in and the robot.
Oh, Antonio Banderas movie, right?
Was that it?
No, you're thinking of
What was the name of that movie?
I got the name of that one. I saw that too.
It's
what
Ex
was it
Machina.
called?
Yeah, the Ex Machina, yeah.
Ex Machina, yeah, that inspired me too to start in that direction. So between Sophia and Ex Machina.
That's actually from Star Wars.
I also ordered a mini Sophia, so that's going to come in a few months or years.
Yeah, I did too.
You did too?
Yeah.
Yeah, it's a Kickstarter.
Thomas, do you still have your orchestra? Your orchestra?
Me?
Yeah.
Oh, Bob?
Hello, Sergio, is that you?
It's me, Bob. How are you?
Yeah, good. I see you can hear me.
Bob's there. Hi, Bob.
Hi, I wanted to tell Sergio that I still have the orchestra and the Apple Store picked up our music last week. And so I've been on lockdown for 2 months and I got burnt out working with robots. So I switched back over to music and I submitted the album to Apple and they accepted it. I can't believe it.
Wow.
So now, I'll send Ben the information so you can see all of that. But it got accepted at the Apple Store, Spotify, and YouTube. All you have to do is type in Cabo Verde Dreams, Bob Barboza, and it'll take you to any of those with a Google search. But the thing I wanted to talk about today was I've been on lockdown for 2 months. And I've been eating the food from the hydroponic robotic Mars growing platforms. I have 2 of them now. And now I'm working on the little miniature ones to germinate the seeds even faster. So next meeting, I'll have everything ready to do a show and tell. So you'll see these 2 beautiful robots on my front lawn growing all the food that my wife and I are eating when we're in our vegetation, vegetarian state. And it looks like we're all going to be in the vegetarian state soon because of the meat packing places. So,
Yeah.
so I miss the days when I could come to regular meetings. This lockdown stuff is not fun.
So Bob, this is Buzz and Linda. Do you still mess around with your Now robots?
Yes, as a matter of fact, I sent Ben a link because my Now robots are teaching kids yoga that are doing homeschooling.
Oh, wow. How cool is
So
that?
we were able to, if Ben doesn't still have the link, I'll send it to him again. But I've got a robot that is teaching kids how to do yoga.
Wow.
And I did a photo essay so you can see the kids, because the last thing I did for the Robotic Society was I did the Clippers event at the convention center. And the day after that, the world went on lockdown.
Oh, God.
And I had to really be a nutcase to do that event, because when you see the photos, I was never surrounded with that many kids in my whole entire life.
Wow.
It was a tremendous turnout. And then, of course, in the next couple of days, the whole world discovered we're not supposed to be in crowds like that, and we should be wearing masks in the whole 9 yards.
Yeah.
So,
well, thank you for sharing that, Bob.
okay. So I turn the floor back over to the group.
Oh, I got something real quick because I'm tired of holding it. I got a choice. All right. How many of you have seen The Mandalorian? You have seen that little guy right there?
Oh, yeah.
He's the best.
All right. So I built one of those life size and I finished it, but now I'm doing an animated one.
Oh, that's beautiful.
It's humongous, yeah. So like this guy, you know, he can move his, if you see on the video, you saw him moving. They are all move independent, all the different options in here. And yeah, it's a whole bunch of bearings and servos and links, you know, the usual 3D printing kind of stuff. And yeah, it's a lot of fun. So the goal is to have the effect, you know, kind of like that guy right there, right? So I did already finish a big one like that, so full size looks like that. But now I want to animate the whole thing. So let's see what happens.
Did you are you having to design the mechanics yourself, or is there any guides?
It's a group. We have a group on Facebook that we're coming up with all the different parts for it. We just collaborate every day or every week.
Nice.
So yeah, so right now I'm also trying to figure out the lights that go inside, but I want to learn about neopixels, and that's turning out to be, you know, pretty interesting. I didn't know that there were so many types, and that they
I have some for Johnny Five's eyes.
yeah, there's so many types, and so for the BD1, like the little droid that was shown. There we go. Yeah, like the BD1, this is a neopixel panel. There's a guy in England who designed the little panel for the back of that little droid that she was showing earlier, the foam. So I'm also making an animated one. So it's gonna be fully animated, the eyes, just like in the video game. And it's gonna have all the lighting effects and all that stuff. So anyways, I'm also building an R2-D2 with arms and legs, you know, big, like legs, like regular legs and regular arms. Anyway, so yeah, I've been pretty busy, you know, doing all kinds of crazy things. And I have, you know, I don't know how many of you missed it, but I have my garage full of different droids already that I made. And anyways, yeah, just busy building all kinds of things, crazy things. Learning Python. Parallax has this little robot now, and then they sent me this for free. But this is now we can use that microbit. Remember that presentation that Alan and I did? So Parallax now has a full-on board for it that mounts on the Bowie bot, and they got some pretty interesting examples, including some cybersecurity examples and things like that. So it's pretty cool. So I'm learning how to use that. See if it's something that I want to use later on. But anyways, all kinds of things. There's so many projects in the garage right now.
Hey, Walter,
crazy.
is
Yeah.
the R2 that has legs, is he supposed to be like the fairy robot from Mandalorian?
That's exactly what it is.
Very
Kind
cool.
of. I don't know if you can see it there. You see the legs or no? You can't really see the legs though.
That's awesome.
But yeah, maybe this photo will show you better legs. You can't really see them, but I took the legs from IG-11 and I made them bigger and I modify them. And I took the arms, and that's what's going to be in that. And it's going to just roll on a platform of electric wheelchair motors. Anyways,
Walter,
that's
if you turn off your camera, just click the camera thing on your camera. You go away and all we see is your background, so we can see the image better.
Oh, if I do stop video? No.
Oh,
No. If you pause your camera.
Oh, sorry. Yeah, you're right. You're right. But you can't really see the whole video, right? It cuts it. I mean, the whole photo. It's too big. Too big to see it. But anyways, I'll come up. Maybe somebody else can go, and then I'll look for a better photo to show you, so you can kind of see the progress of it. But yeah, go ahead.
All right.
Thank you. Pretty cool stuff.
Very cool.
Yeah.
Very cool. Was that a power droid torture robot I saw in the garage?
Yes.
Melting
So
droid,
I
yeah.
have I think the better idea here. I'll do something. Why don't I? Can I have the floor real quick, and I'll show you some photos real quick.
For sure.
Okay. All right, just real quick. Let's see. The beauty of I know you all hate Facebook, but it's so easy to maintain an album in there. So I have all these albums of all the different droids that I've been building. So like Fairy Droid. There you go. So you can see the legs right there, and these are gonna be the arms, and this is gonna be the fairy droid on the Mandalorian. So I got inspired when I saw it. I know everybody hates it, right, Rob? Rob is part of the droid builders, by the way. And everybody hates this droid in the droid community. So I said, well, because they hate it, I'm actually going to build one.
It's ungainly.
Well, if you don't like that one, I thought it was cool.
Well, some people don't like it. But yeah, Smelter Droid, which is the torture droid, I finished that particular one. And he's right here holding Baby Yoda. He's a big one. It's a humongous.
Oh, you got him sitting down, yeah.
Yeah, he's too big to, I mean, he can stand up, but he's way too big. He's humongous. This is all 3D printed.
Filling up your garage with these.
Oh, the garage is already packed. I mean, this is
Bring them in the house yet?
I know that's what my wife says. If you keep building these things, you're gonna need a. And we're always having fun when we when I take these droids out there. Let me show you a couple more here. Let's see. Oh yeah, IG-11. So here's the IG-11 completed. He's humongous. And this is actually printed at 90% of the real size. The real size is like 7'7". This is about 6'2" or something like that. It's down like 7 inches. I forget how many inches, but so he's done.
Well, you say done. You haven't animated him yet. There's no motors in that.
Not on that one. This is the one that I'm animating right now. So yeah, not on that particular one.
That looks good, Walter.
It
Yeah.
should have actual shooting mechanism, right? I mean,
Yeah.
anybody builds those, you know, with real guns like this?
There's a C-3PO that I made last summer.
So Walter, how long did it take you to 3D print all the parts for that?
I've been printing nonstop since June of last year on 3 printers.
For that one robot?
No, all of them. I can't really tell you like how much each one took because I work on all at once. I don't finish one and then I go and I print parts randomly for all of them as I assemble them.
So what is your current ongoing count of the different robots that you're working on?
I lost count actually. I have no clue how many I'm actually. I have lost count, but if you see this photo here, I basically built all of these and a lot more. I actually designed this and I had a guy, an artist, redo it because I did like the chicken scratch and then I had an actual artist redo it for me and he did a beautiful job. So this is me on with the costume and these are the droids. But then I built a whole bunch more after that. This is actually, here's Rob right here. He's helping me, there you are, Rob. He's helping me build my wooden R2-D2. This is gonna be the real R2. Yeah, so this is my wooden frame, so I don't trust the 3D printing frame. And eventually it's gonna be looking like that. So we had
whose house was that?
This is Tina. She also has frames that she's building.
Oh,
so
okay.
we're all building it at the same time.
Oh, cool.
And so we meet from time to time and we build them. And then, oh yeah, so here, giant one. Let's see, what's the other one? There was another one. Oh yeah, so there's the other one right here. Oh, I'm also doing a mouse droid. I don't know if you remember. In the movie Star Wars, there's it's just an RC car basically with this particular frame and a few little extras on there. So I got that one. Let's see, what's the other one? Baby Yoda. Oh yeah, lots of pit droids, by the way. I've completed 3 different pit droids, so this is one of them.
Oh, you got it washing your car, did you?
Yeah.
That's good.
This one is folded.
Oh, I got one that's collapsed. That's cool.
That's collapsed, and then I have this one too. This is a different one.
Oh, that looks cool. I like that one.
Yeah. So those are the 3 different pit droids from episode 1. Anyways,
all the model files.
All the droids that you've seen in the movies, you know, I got a whole bunch of them made in here.
Where are you getting the files from?
Different groups online. So you join the groups, and then somebody will design the you know, they'll model it, they'll put the parts up, and then you build it, and then you provide feedback. We'll change it and go back and forth until we get them done the way that we want to. So, but it's a you know, it's different groups for different droids. So each droid has its own group.
Yeah, I'm in a couple, and Tom Walter's in more than I am. So.
Yeah, so it's a whole bunch of them. Oh yeah, and then the last one is where'd it go?
How many spools of PLA are you saving
by
those
now?
spools?
There's probably at least 60 spools that I've used so far, maybe more, maybe like 60, 70, something like that.
Are you saving them?
I've used some things for other things, but mostly I just discard it. But I have used them for other projects, parts of it. The centers, for example, I've used them for other projects. All right, and then the last one was, which I don't see an album for it, it was the Battle Droid. What the heck is the Battle Droid?
Well, you got pictures of it somewhere, I think.
There's no Battle Droid, Protocol Droid, Pit Droid, Oscars. Maybe I never did a... Well, maybe you can see part of it in here in this. Here's one of the actors from The Mandalorian. Oh yeah, and he's signing one of my droids. So he's signing this guy that I did. This is a Battle Droid. And it's got some unusual colors. I saw one of those buses, you know, with the blue and the orange colors, and then I saw a taxi next to it. And I just got inspired by the colors, and I said, you know what, I'm just gonna paint it that color. So I finished 3D printing this guy. He's big, and I just painted those colors that I saw at the moment. So all my stuff has colors that are not matching the movies. I cannot make replicas. I just, I'm not good at making exact replicas. So I have to put my own spin on all these things. But yeah, so I got invited because I do all this stuff, I get invited to parties. And at this party, we watched the episode that he was in. He's Gecko, one of the bounty hunters. And, you know, I brought this guy and he signed it. So anyways, that's that. I know it's crazy. It's been a crazy few months ride that I've been printing quite a bit. Yeah, I've been printing a lot. Like I said, since June of last year. Yeah, almost nonstop. It's a huge process. For those of you who don't know how this thing works, it's a humongous process. You have to prime them, you know, after you print them, then you got to sand them and fix them and paint them and glue them and all kinds of things. So each one takes a considerable amount of time. And of course, you got to do all the safety things with the mask when you're painting and all these things, and
oh yeah,
gloves, and there's a lot of processes and steps. And I love playing with the paints. I even bought a airbrush, so I'm learning how to airbrush. And you can do little effects, like you can spray like darker colors in between the lines like this, so you can make it
add highlights and
you know,
stuff.
make it look like it's been used or old or it's been in battle, those kinds of things. I love learning how to weather things, and so I'm doing a lot of that stuff right now, and it's just a lot of fun. So
yeah, nothing wrong with that.
Yeah.
Walter, you mentioned that you have 3 printers. How they are holding? I mean, obviously with that much printing, you have to repair them, or
yeah.
holding well? Tolerances, are they still good after a while?
Yeah, you know, so there are 3 different ones. What goes bad with them mostly is the extruders. So I've had to replace a couple of extruders. But that's about it. Power supplies, belts, all that stuff holds well. I still have to adjust them every now and then because the belts get loose, or some of the parts just get loose, and you just have to retighten them. But yeah,
Hey,
a couple of extruders, and that's it.
Walter, what do you do for temperature control?
In what respect, like the whole garage inside, or?
Yeah, because you know, you got such big pieces. If something were to go wrong, it would be disastrous.
And he's had
Yeah,
it go
you know
wrong,
what?
too.
Yeah, that is a good point. So little things like if I open the garage door and things are printing, the little bit of wind, the cold wind that can go in, it can actually mess up the print, believe it or not. So you got to keep the temperatures constant. I print my stuff a little hotter than recommended. So in case something happens, the bonding is better. It's just the plastic melts better. And so I print my stuff like at 220 or 230. I know most people use like a 210 or 215
Hey,
for
Walter,
PLA.
What about the balance, where you gotta have a level platform before you embark upon such a gigantic project?
Oh, I'm a pro of that now.
So what do you do to keep that balance?
I can what do you call it? Calibrate a bed with my eyes closed now.
Well, not quite that, but yeah, it is an art to level the bed. I tell you that.
Yeah, that's an art form in itself.
Like Walter, I'm getting good at it too. Plus,
Yeah. So I actually was teaching Tim how to do that, how to level the bed, because
oh yeah, that helped out a lot. Thank you.
that's probably what frustrates more people, and they spend a lot of money on auto levelers. They buy these auto levelers to auto level the bed. I mean, it's fine if you don't want to mess with it, but I know how to level the bed so good now that
I had one.
I don't need any of that stuff.
Here's something real weird, Walter. One of the legs on my Yoda character had an earthquake at the time, and I could see the vibration in the plastic.
Yeah.
So Walter, what do you do if there's a interruption in your print job? Do your 3D printers have memory so they can pick up where you left off?
They do, yeah. Yep. So they can go back to exactly where they left off at.
Mine has it too. It's a thing. If it loses power, it will remember where it's at, and when the power comes back on, it'll start where it left off.
Yep.
Has anybody put a
Sometimes it won't start where it left off, but most of the times it does, and it works pretty good.
Yeah. So yeah, they do. They have a, but yeah, 3D printing. It's once you've done 6 months every day of it, you know all the ins and outs of it and the little, tricks and techniques. Like I still use a little bit of hairspray on every
Yeah, the only
part.
thing that would make it better is if you put them. Oh no, I don't.
Yeah, so yeah, even using a little bit of hairspray on things, I still do it just out of habit, so things can stay,
You print ABS or PLA?
I've done everything, ABS, PLA, PETG, but I do PLA mainly because it's non-toxic. Even though I hit the print button and I go back inside the house, I don't deal with smelling it or anything like that. But
So
PLA non-toxic is better. I have printed a few parts on PETG and some ABS as well. It all depends on what I want it to do.
Yeah,
So what is the hairspray used for, Walter?
So that it can glue to the bed.
What do you mean? Do you spray the bed first or something?
I sprayed the bed first, yeah. And so the first layer of the plastic adheres to the bed much better if you have it. It acts like glue, basically.
Oh, yeah. Okay.
That way, as the head moves on top of the part, it won't move the part, and you won't have a failed part.
Yeah.
Yeah, I've been using glue, and I've had good success with glue. And of course, Walter, when you and I started out, we used to put down the blue tape.
Yeah, the blue tape was the old thing that people used to do. Yeah.
So nobody's doing blue tape anymore.
I think some people still are. I don't know if Alan uses anything. Do you, Alan?
No, I switched to PEI sheets a few years ago, and I haven't looked back. I've had great results.
Oh yeah,
similar to Build Tech, I think.
That's right. Yeah.
I use blue tape.
This is Ben's design of the Mandalorian symbol. Thanks, Ben. I printed a few of these and painted them.
You're welcome.
They look pretty cool.
Yeah.
Here's a baby Yoda I gave to somebody at work, gave her as a present, and she took it to Disneyland, Galaxy's Edge, and then she had like thousands of hits on her photo on Instagram and all that. But she did an awesome job of repainting it, because I painted it kind of crude, but she repainted it beautifully, made a little costume for it, and glued some hair on it. It was pretty amazing. And then she broke it. Well, here it is. I mean, she did a really good job. Look at that first visit. The shop. Look at the eyes. I mean, she was amazing. When I did mine, it didn't look as good. I mean, there's my paint job compared to her paint job. Anyway, so here's some Here's an event at Hollywood for the last movie last December. I was in charge of managing all these guys at the movie premiere. And so we were messing around in the parking lot at the Man's Chinese theater. So anyway, so yeah, I've had so many opportunities because ever since I got into this just a few months ago, just in a few months, I've had some amazing experiences.
Well, since you have an official costume with them now and everything.
Yeah, exactly. So I get invited to so many things now because of this stuff, but it's fun. And so now that I've done all this, the next step is to, as you saw, now I'm animating all these things, figuring out how to animate all this stuff.
Oh yeah.
And so that's the next thing.
I'm probably going to build a full-size Yoda myself, and I may animate the head and the eyes a little bit.
Cool. Yep. Anyways, thanks for listening. This is a whole bunch of stuff here.
Hey, thanks, Walter. You've been up to some amazing things. Prolific,
Walter.
is the right word?
Yeah, thank you. Yeah,
Indeed, very nice, Walter.
It's been a crazy ride.
Yeah. But you love it, so what do you know?
Yeah.
You like it, so.
Yeah.
As Maxwell Smart would say, and I love it.
All right. Well, thank you so much. Now let me unshare so that somebody else can go. I don't want to take up all your evening here. Oh, there you go. You can check me, Alan. Did I? Oh, here we go. Stop share. There you go. All right.
Hey, there you're back, Walter.
Thanks, Walter.
Thanks,
Sure.
Walter.
You're welcome.
Okay, I am going to take off, but it's really great connecting with you guys. It's been really lonely here, that's for sure. And I never thought I'd see you guys again. So, and especially to see Sergey and his tractor.
I know.
I don't know what state Sergey's in, but all I can say is keep your mask on and stay away from people.
Good to see you, Bob.
Quick shot of Johnny before you go.
Oh yeah, there you go.
Hey, Johnny
I want to see that one in person one day.
I can share a picture of what I got wired up in my bot if you want to see it.
Oh yeah, Les has a walking bot.
It's not there yet, but this will show you what's going on if it'll share up.
Oh, there you go.
And so it's really crowded in there. I'm surprised. I didn't really expect to end up with as many wires as I did. But I've added this little thing on the side. I don't know if you can see my pointer there. On the left side of the bot, there's a little piece of metal there.
What's that for?
That's the homemade heat sink for a FET switch for the power.
Oh, gee.
So, because what it's going to take is about 8 to 10 amps when this thing's running.
Yeah.
How big is this?
This is it's about 40 inches tall, I think. 20. I don't know exactly how tall it is. About it's taller than my 27-inch monitors. So the and I added another servo because I originally designed the feet just to have the roll-on axis on them, and I redid another servo, so now I have pitch and roll both on them. So now the legs have like 6 servos on each one.
What is it? What is it you're making?
It's a walking robot.
Oh, okay.
See, I think I got a picture here. Let me see if I can find that picture. What would that be? Oh, probably in here. If I go, let's see, my iPad and documents.
Yeah, I got to see the real Johnny 5 once. I went over to the guy's shop when I was working in another company, and he showed me it.
I don't see that picture here. I must have deleted it accidentally. I've got the display, pictures of the face mount. Let's see if that shows. I don't know. How do I share that now? Let's see. There should be another share button here somewhere, huh?
Down at the bottom. Hi, Phil.
Right there. Now then. Come on.
You can just close this one out and then reshare, and it'll select whatever you want to share.
Ah, there we go. Okay. I'm not the brightest candle on the cake when it comes to this stuff. So this is the face mount, and you can see how the wires come out of that. Then they go down through that neck post on the other drawing, on the other picture, and they go into the Raspberry Pi. And you couldn't tell it from the picture there. So much stuff over the top of it. There's a Raspberry Pi 4 buried in the bottom of that. So what I have, this is a little display that will show a face on the front of it. And let's see if I can get that picture up here. I think I sent you all the email showing it making a face. But some of that stuff is hard to do because it doesn't, let's see. Yeah, here it is mounted. This was while it was still white, so I'll share this now. Okay.
Oh, that looks cool. I like that.
Okay, that's the head. And it has internally 2 servos that will turn the head back and forth and make it nod. And I reprinted this in the body in gray because I just have different colors I print in. I print in whichever color PLA gets into my hands.
Yeah.
It's a prototype, you know, I've got about 10 different colors in there. So the thing is that I keep adding more features, and as I add a feature, I have to reprint stuff. So at this point, I have everything just about mounted in that gray box. So everything looks pretty much like it's going to come together all right. The wires that it showed in there didn't yet have I think it's 5 wires or 7 wires that has to come down from this head, which runs the display. At this point, they're just hanging out the neck gap, which is where the head can rotate back and forth for nodding.
Okay.
And then if I go to, let's see, this shows you those head mechanics in place. I got to move it over so I can get to the share button.
Oh, yeah.
So the servo that's crosswise here, the top servo, is the one that will make it nod. And I've changed this. Originally, this was done with 2 pieces of plastic straw as the spacer, but I've created new spacers that has an arm and a socket so that it will tilt the head more directly in proportion with the action of the servo. And the rotation is done by, you can see this groove in the neck piece there. That has a tongue that sticks out. So this platform, the 2 pieces and in the slot, will move back and forth and swings the whole head to represent turning the head back and forth. And then there's a small servo here that links up to that arm, and that's what moves it. So both servos are moving with the head, and the head rotates on top of the stem. That was my kludge. I couldn't figure out how other people did it. That's just the way I came up with to do it.
Well, it's more than one way to do a pan and tilt mechanism.
Yeah. You know, you get what you get, right?
Yep.
Well,
Hey, Les, are you still using OpenSCAD to design your parts?
Yeah, I always use
Nice.
OpenSCAD. I'm a programmer. I'm not an artist. I can't
Nice.
draw anything for crap. I used to do mechanical drawings in the old days with the squares and the triangles and the sliding bracket on the big table and all that. And I can do that pretty well. But boy,
Nice.
if I have to try and draw it with a computer, forget it. It is not going to look like anything. I tried using that Autodesk 123, I think it is. And I tried using SketchUp.
Yeah.
And I could kind of get crude stuff, but I can do really nice stuff because I can take my time and write my programs and get the numbers all right and line the curves up and everything, you know, like the curves on that head. that's done by using spheres and arcs and subtractions from solid objects.
Right.
And I make the one cube and then I shrink it and put it inside the cube to get the hollow space. And I can get any shape I want. It just takes me a little more time to think about it, but because I'm used to programming, it works pretty well.
Yeah, I like OpenSCAD. I don't know. It's just, it takes a long time to do anything, but it's kind of fun to figure it out. Like you said, carving out solids and things like that. It's fun.
I won't show you all of it now, but I've written a document about the robot and its evolution. So I'll pack that up and we can put it on the website later. So if anybody's really interested in trying to build this thing when I get it done, if it ever works, I don't even know if it'll ever work. I started working on some of the code for the pace, the walking, and I figured out that I'd have to swing the arm to help balance the body as it moves. So it's going to look like it's a pretty natural walk, I think, when I'm done. But we'll see. The feet had to get bigger. I figured that out in order to get the pitch and roll both on the foot. The feet had to get bigger in order to support the extra servos and have enough space on there so I felt comfortable with it. The whole bot right now it's getting to be a little bit of weight. It's got 20 of the big DS 3218 servos, the 25 kilogram servos. And it's got the 2 of the mini servos, and then there'll be 2 mini servos on each arm for the grippers and rotation of the wrist. So that's going to be a little more. And then I'm thinking about adding a rotation servo for the arms too, where they come off the shoulders. So I've been sketching that out to see if I can get it to work the way I want it to. I'm trying to keep it so I don't have the big servo sticking up above the level of the shoulders, because I don't think that'll look right. But I don't know how I'm going to end up doing that. Some of this stuff is a lot harder when you start trying to lay it out and get it to work with servos. If I could do the wave motors like Alan was working on, that would work pretty good. But I'm not skilled enough at the printing, I don't think, to get that to come out right yet.
Not yet. Not yet.
And I've got some stuff that fits together pretty well. I mean, you saw some of my fittings. I just completed my first block fit on covers for the battery compartments. So I did what I did was a cylinder along a channel. And then I put the cylinder at the edge of the pieces that slip inside. So it just friction fits, and then they pop into the channel when they're all the way in. So it fits really nicely and it sets up nice.
Cool.
But that's about where I am right now. I've got all the pieces, the arms and the legs assembled. I've got the body almost wired up. I've tried the servos. I know the servo drivers will work. I know I can serialize the 2 servo drivers, and I'm using the output of the servo driver then to drive the BN055, which is the IMU unit. And that's a really nice unit. I don't know if you guys looked at the specs on that thing, but it has the Kalman filter and the little computer inside of it. So you get smooth vectors out of it already for your rotation and the angle you're facing and all that. So it runs really smooth. And they said there was a problem with the Raspberry Pi because of the I2C pulse width stretching or clock stretching. But I ran it full tilt like I've got it set up, and I never had a problem. It ran continuously at all speeds without any errors. So I'm getting close. I think probably by the end of this week, I'll have it all assembled. I'm a little worried about the current draw and the battery, so I'm going to probably take it outside to fire it up the first couple of times with a fire extinguisher standing by just in case. I accidentally tried a little welding with those batteries, and they'll do the number. I about welded my little jeweler screwdriver to the terminals.
Oops.
It's got a divot in it now. So
That's a lot of current.
Yeah, the 2 of them, those 2 18650 batteries will produce 8 volts, and at 20 amps, it didn't even drop. I mean, it was like a 10 milliamp or 10 millivolt drop.
Oh, gee.
So I got to be careful with those terminals. So I've got to put a, that's the other thing I didn't do. I didn't put any covers on the terminals yet. So I got to do that.
Oh, that's doable.
By the way, if anybody needs an 18650 battery charger, I have a spare one. I ordered one and I lost it in my melee of parts between here and the garage and company coming in one thing and another. So I couldn't find it when I needed it. So I ordered another one. So if somebody wants an 18650 battery charger, I'll give it to them. And it'll charge four batteries.
Oh, gee.
And
Well, they're sealed lead acid batteries or what?
No, they're lithium ion. That they're the typical ones are 20 to 30 amp high end at a 3 amp hour capacity. And
wow.
Without a BMS.
All kinds of stuff. I'm sorry?
I said flying without a BMS.
Yeah, you can be a real far starter with them. Okay, guys, I'm done.
Hey, Walter, you still there? Is Walter still there?
Yeah, I'm still here.
All right. I don't know if you can see this or not, but I got a picture of the DJ Rex here on my computer laptop. I'll turn the camera around, see if you can see it. Do you see it?
Yep.
Yeah, that's what computer model of them is. There's guys actually.
Nice.
That's a 3D model of it.
Very cool.
He's working on. That's actually in Galaxy's Edge. There's the head.
So that's your next project, right?
Yeah, it's the next one I do after Yoda here.
Yeah, good.
Start with the head and work down.
Alan,
Go ahead.
last time, this is Mike. Last time you were wondering about printing nylon, Alan?
Well, I haven't successfully printed nylon yet. So I've got a couple of failed attempts, and I'll bring all the samples down to our next in-person meeting. That's actually one of the few materials that I've never been able to get stick to the build plate. I haven't figured it out yet.
I've printed it before. I use build tack with a glue stick.
And you got it to stick?
Yeah.
I'd be interested to know what brand of filament that was, because every time I've tried, I've failed so far.
It's Tallman.
Mm-hmm.
Taulman.
Huh.
Yeah. Yeah, it's hard to print, but if you use glue stick with that build tack or a gyro light, also works.
Huh.
Are the settings kind of like ABS settings?
I forget.
Pretty hot or?
It's pretty hot, yeah.
Yeah.
Yeah, since my printer's in the room, I can't do ABS. I'm doing just PLA stuff.
Yeah.
Like this is nylon.
Oh wow.
Wow. Okay, that turned out great.
Big part, yeah.
Better than all my nylon parts, or the few that I tried.
So, yeah, I can. Well, anyway.
Cool. Thanks, Mike.
Yeah.
Walter, I finally got that Disney thing on the Mandalorian to load.
Oh, nice.
I'll watch it when I'm through.
Behind the scenes.
Yeah, I finally. Well, I mean, it showed up, but it wouldn't let me load it till just now.
Yeah.
I guess they have episode 1 done, and they got 2 and 3 listed, but they haven't. I guess they haven't aired live on TV yet.
That's cool.
Yeah. Yeah, I watched the. What did I watch recently? Oh, I watched episode 5 again, which I wanted to look at because they had the medical droid in there. I got all the 3D files for the medical droid now.
All right. Nice.
Cool.
Have you played that that album thing I gave you a copy of?
I have, yeah. Yeah.
It's pretty cool cantina music, huh?
It is, yeah. Yep. That's good.
I thought until you printed one of those yourself, it'd give you the Star Wars mood there, you know.
That's what I play when I'm building them.
Okay. Well, it's got quite a selection in there, you know.
Yeah. Very cool.
Yeah, in the files for the DJ Rex 3, has all the stuff that he's saying, and it's just stuff in there, you know. I guess they're still using Paul Rubin's voice because it still sounds the same as what he did in Star Tours.
Cool. Well, an update on the campus. They still haven't said when they're opening the campus officially. So, yeah, we're still waiting to see what they say.
So it's still locked down at the campus there, it sounds like, huh?
Yeah.
Okay. Well, cross fingers, man. I'm going to get this thing painted this next week.
My grandson's going to Cal Poly. They told him that they're going to continue the spring semester with online classes. So it looks like they're not even going to try to open in spring.
You mean fall?
Summer.
Wow.
Fall. I mean, yeah.
Okay.
I've been thinking springs all day because I was looking for springs for my boxes.
Oh, funny, funny, funny.
Yeah, especially a lot of those instructors, you know, they're 65 and older, so that could be pretty dangerous for them.
Oh, I don't think I've shown you a picture of this guy in a while. Hold on a second. Can you see him?
Oh, yeah.
That's Tommy. My ventriloquist will figure I haven't finished getting this mechanics working yet.
Mm-hmm. All right, so it's about 8:30. We ran a little bit long tonight, but I'm glad everyone's here and is looking healthy and doing well. And I don't know about the rest of you, but my cup's always half full, so this provides a lot of extra time to build robots and do robot stuff.
Yeah.
Desperate to talk
Yeah.
to somebody.
I'll go see how well I can paint this thing. I don't know if I can do the magic thing with the ears that you did, Walter, but I'm just going to paint it all green for right now and get the base color down.
Okay.
Very cool. I think we're about ready to wrap up. Ben, do you have anything to bookend this meeting with?
I'm saying what?
Just wish everybody to stay well. Next meeting, we have Dr. Morales, which is he's going to come in and give us an update on the progress of the swarm robots. So that should be fun.
Oh, yeah.
Excellent. I'm looking forward to it.
Right.
All right. Thanks, everyone, again. Have a good night. I'll see you in 2 weeks.
All right, everyone.
All right.
Good seeing everyone.
Talk to you later.
Thanks,
See you, everybody.
everyone.
Stay safe.
Stay
All right,
safe.
bye.
Be well.
See you later.
See you later.
Okay.
Thanks, Alan.
Thanks, Alan.